Hey there, folks. Now that the wall-mounted computer build is finished, I'd like to show you how I monitor the energy consumption for my electronics hardware. In the olden days, I'd use P3 kilowatt devices for energy monitoring. But with modern technology, I can accomplish the same thing while unlocking even more capabilities by using IoT smart plugs along with an integrated monitoring platform. My smart plug of choice is the Sonoff S31. These have been dependable units that allow me to track the statistics I'm interested in and are relatively cheap. Another important characteristic is that as of the making of this video, the S31s are manufactured with ESP microcontrollers. This allows us to flash a custom ESP home firmware to the device, which enhances our ability to tinker with its settings at a deeper level than the stock firmware allows. This monitoring solution enables me to research and answer questions like, how much energy does my networking equipment use? How long might the switches function once running on battery backup? How much does it cost me to run Cyberpunk 2077 benchmarks? What's the usage in watts for an extended Skyrim session? And many other similar questions. There are 3 steps to getting everything in place. First, we'll set up a virtualized instance of HomeAssistant on the Windows Hyper-V platform. Second, we'll disassemble a Sonoff S31 smart plug and flash it with the latest ESP home firmware. Third, we'll import the flash device into HomeAssistant and create some basic graphs using out-of-the-box sensor configurations. In this video, we'll focus on setting up Hyper-V and the HomeAssistant instance, and we'll cover disassembly of the Sonoff smart plug and the flashing of custom firmware in an upcoming video. Fair warning, these topics are complex. I've done my best to try and balance information to video runtime, but what I've covered here is a drop in the bucket to what you might discover on your own. I'd like to start by calling out that Hyper-V is limited when it comes to USB pass-through support. The world of home monitoring and automation hardware is quite expansive, and includes devices whose connectivity relies on USB. As such, Hyper-V might not be a great choice if you'll be integrating USB-based devices. An example would be something like the Zigbee USB dongles. A path to enable USB support in Hyper-V could be USB over IP devices, but those can get pricey. Do note that these devices are not the same thing as USB over Ethernet extenders. Totally different products. There are also other options for virtualized hosting, including VirtualBox, VMware, and others. I'm personally a big fan of the Hyper-V virtualization platform, which is freely available in professional and enterprise versions of Windows 10 and 11. While there are a number of different methods to stand up HomeAssistant, I'm already well established with the Hyper-V ecosystem, and I won't be using any USB devices, so it made sense for me to use Hyper-V for HomeAssistant as well. Before jumping into the Hyper-V setup, let me suggest the following actions. Step 1. Take a full system image of your working machine, which would allow you to restore it to a working state in the event of a problem during setup. I use the free version of Macrium Reflect for this task, but there's lots of options out there for system imaging. Step 2. Decide on your networking strategy. Personally, I like to dedicate a network adapter for Hyper-V's use. Here are 2 relatively simple options you might consider. Many motherboards come with multiple network ports. If you only use one of them for your primary network access, you could configure the Hyper-V virtual switch to use the other adapter. A second option would be to buy an additional PCI or PCIe NIC card, install it in a spare PCI slot on your motherboard, and then use it for the Hyper-V configuration. There are other options you could explore, but certainly as a beginner or first-time user, I'd recommend one of these 2 approaches to try and keep things well segmented. In my case, I use the motherboard's onboard 10 gigabit network adapter for the host machine's network access, and have installed a separate Intel X540T1 10 gigabit PCIe Ethernet card for the VMs in Hyper-V. Both of those network adapters connect to a Netgear 10 gigabit Ethernet switch. Let me quickly show you this machine's network configuration. I'll right-click Network on the desktop and click Properties. Next, I'll click the Change Adapter Settings link on the left side of the window. In this test system, I currently have 4 network adapters, 2 of which are disabled. The Ethernet entry is the motherboard's onboard 10 gigabit Ethernet adapter. The Intel X540T1 10 gigabit Ethernet adapter is the PCIe add-on card that I've added to the system. By default, Hyper-V will create its own virtual switch named vEthernet Default Switch. In my experience, this network adapter will create an internal network that has a 172.IP range. If, in your experience, you are savvy enough to manage the default switch, or create an additional internal switch via PowerShell scripts and NAT configuration, then you might be just fine with the default switch that is created. For ease of connectivity and management, an alternate option would be to set up what Hyper-V calls an external switch. An external switch is a virtual switch that is bound to a physical network adapter in the host system. Using an external switch can make it easier to connect to other network endpoints, access the internet, and generally requires less rigor when it comes to NAT setup and/or port forwarding to ensure that assets can talk to one another. A weakness in using an external switch in Hyper-V is that it allows virtual machines direct access to the wider network, and thus isolation of the virtual asset from other resources is not as robust. This doesn't mean that an external network switch is inherently a bad idea, nor is it inherently a good idea. It just means that you should exercise some wherewithal when it comes to your network security posture and to understand your risk vectors before setting up infrastructure of any kind. In this demonstration, I'm going to create an external virtual switch in Hyper-V, and I'm going to bind it to the Intel 10GB NIC card. With this configuration, the Intel adapter will be dedicated to the VMs I create in Hyper-V, while the onboard Ethernet adapter will handle communication of the host machine to the broader network. I'll close the Network Connections window, and then close the Network and Sharing Center. To get started with Hyper-V, you'll need to enable the virtualization capabilities in your motherboard's BIOS. Depending on the manufacturer of your motherboard, and whether you're using an Intel or AMD platform, the options you'll need to enable might be named differently. Common examples are Intel VMX Virtualization Technology, Intel Virtualization Technology, VTD, SVM Mode, AMD SVM, and probably others. My recommendation would be to reference your motherboard manual and follow the instructions to enable the virtualization capabilities of your system. Once the virtualization extensions are enabled in your BIOS, boot into Windows, 64-bit Professional or Enterprise, click the Start button, and type Turn Windows Features on or off. Click the app when the name pops up. In the Windows Features list, scroll down to and enable the Hyper-V feature and both of its sub-selections. Click the OK button, and when prompted, reboot your PC. These are the simple steps necessary to set up Hyper-V in Windows 10. If you are using Windows 11, Hyper-V can be enabled through the Control Panel or the Settings menu. You can also use PowerShell scripts to set up Hyper-V on both operating systems, if that's more your thing. After the reboot, I like to add a Start menu shortcut to Hyper-V to make it easier to interact with the management console. To create this shortcut, I'll click the Start button, click All Apps, scroll down to and expand Windows Administrative Tools, right-click Hyper-V Manager, and click Pin to Start. Now, when we close and reopen the Start menu, we'll have a link to Hyper-V Manager front and center. Let's click the link to open the console. In the left pane, under the Hyper-V Manager heading, I'll click the server name. Hyper-V by default uses the machine name as the server name. This test machine's name is server in all caps, so that's the Hyper-V instance name as well. Next, in the Actions pane under the server heading, I'll click the link labeled Virtual Switch Manager. On the desktop, I'm also going to right-click the network icon, click Properties, and then click Change Adapter Settings. One of the oddities of setting up Hyper-V is that on some hardware, it can take some time to provision and set up the default virtual switch. I've had it take upwards of 15 minutes to complete this step. While you see the loading message in the Hyper-V Virtual Switch Manager, continue to hang out and wait for the adapter to appear. After roughly 7 minutes, a new adapter appears in the Network Connections window, and the Virtual Switch Manager now shows the default switch. I'll go ahead and close the Network Connections window, and close the Network and Sharing Center window. For the purpose of this demo, I'm now going to create an external virtual switch. In the left pane, I'll make sure the new virtual network switch entry is selected, and then click Create Virtual Switch. Next, I'll enter a switch name, and under Connection Type, expand the External Network dropdown, select the Intel Physical Network Adapter, Uncheck Allow Management Operating System to share this network adapter, and then click Apply. Before the switch is created, there will be a warning message that the configuration will disrupt remote access on the selected network adapter. This is technically not a full picture of what will happen. Not only will you lose remote access to the host, but you'll be disconnected from the internet and the local network via any dynamic or static IP configuration that is wiped out as a result of clicking the Yes button. I highly recommend you heed the warning of this message. If you were to bind the virtual switch to the primary and only network adapter in your PC, you are going to lose network connectivity due to the interaction of the virtual switch to the physical hardware. I cannot stress this point strongly enough, and is the reason why I recommended making a reliable backup of your system prior to reaching this step. I can safely select the Intel adapter for VM usage because the onboard network adapter will ensure that I maintain the host machine's ability to communicate over the network, which includes remote and internet access. I'll click the Yes button to proceed. Once the switch is created, I'll click the OK button to close the switch manager. I use a specific nomenclature for my virtual machine storage, and with this being the initial setup of Hyper-V, I'll recreate that structure here. As I go through the next few steps, don't feel like you have to place or name files how I do, as they are just my preferences. I'll double-click this PC on the desktop, and double-click into the F drive. This is where we'll place the HomeAssistant image file and virtual machine. Back in Hyper-V, I'll configure its settings to use the F drive for VM storage. Click the Hyper-V settings link under the server heading in the Actions pane, and for the virtual hard disks path, click Browse, click the F drive, and then click the Select Folder button. When a setting is changed in Hyper-V that hasn't yet been saved, the name of the changed setting category will have a bold blue color treatment. This means that there is an unsaved change. Next, I'll click into the Virtual Machines tab, click the Browse button, click the F drive, and click Select Folder. To save the changes, I'll click the Apply button, and the bold blue text returns to its normal style, indicating the settings are now saved. Let's download the HomeAssistant image. I'll open a browser and perform a Google search for HomeAssistant. Since Google has the installation page listed in the search results, I'll click the installation link. On the installation page of the HomeAssistant website, I'll click the Windows link in the left pane, and once the page loads, I'll click the .vhdx image that is relevant for the Hyper-V platform. I'll download the zip file to the desktop, and once it's complete, I'll close the browser. Next, I'll right-click in the root of the F drive, and do New, Folder. I'll name the folder HomeAssistant. I'll double-click into the HomeAssistant folder and create an additional folder named Virtual Hard Disk. I'll double-click into the Virtual Hard Disk folder. Again, this is how I prefer to maintain my virtualized assets. Don't feel obligated to follow the same pattern. With the destination folder created, I'll double-click the HomeAssistant zip file on the desktop, and then click and drag to unpack the .vhdx file from the archive into the Virtual Hard Disk folder. I'll close the Zip Explorer window, and since we're done with the zip file, we can right-click and delete the file. Finally, I'll right-click the extracted file and rename it to virtualharddisk.vhdx. I'll click the Up Directory button in the Explorer window to return to the HomeAssistant folder. We're now ready to create the virtual machine in Hyper-V. In the right pane, under the Server heading, click New, and then click Virtual Machine. Click the Next button on the new Virtual Machine wizard and enter a name for the VM. I'm going to name the VM HomeAssistant, which is the same name as the folder name here. This ensures that when Hyper-V auto-creates the virtual machine directory, it will be created in the folder structure I manually specified earlier. We'll see this happen in just a moment. I'll enter HomeAssistant in the name field, check Store the virtual machine in a different location, leave the location as F:/, and then click the Next button. When asked about the generation of VM to create, you must select Generation 2 when using HomeAssistant. Select that radio button and click the Next button. While I'm testing out a new VM, I like to specify a total of 4 GB of initial startup memory and increase or decrease that amount as necessary, but select the amount of memory that makes sense for your workload or hardware. I'll enter 4000 megabytes, leave Use Dynamic Memory for this virtual machine checked, and then click Next. In the connection dropdown, I'll select the Intel virtual switch that we created earlier, and click Next. When prompted to connect a virtual hard disk, we're going to use the vhdx image we downloaded earlier. I'll click the radio button for Use an existing virtual hard disk, then click the Browse button, click the F drive, double-click into the HomeAssistant folder, double-click into the virtual hard disk folder, select virtualharddisk.vhdx, and then click the Open button. Click the Next button. Confirm all your selections look good, and then click the Finish button. You'll notice that a new folder named Virtual Machines has been created in the root of the HomeAssistant folder, and this is where the VM configuration files are located. We're done with the HomeAssistant folder on the F drive, so I'll click the X button to close it. We can now proceed to modifying some basic settings for the HomeAssistant VM. In the Hyper-V Manager, click the Settings link under the HomeAssistant header in the Actions pane. First, I'll click the Security tab in the Hardware section, uncheck Enable Secure Boot, and click the Apply button. Next, I'll click the Processor tab, set the number of virtual processors to 4, and then click the Apply button. Assigning 4 virtual processors initially is just my preference. Set the amount appropriate for your use case and hardware. These are the 2 common settings tweaks I'll usually start a new VM with. Later, I'll come back and modify these settings according to how the VM or workload is performing. As you can see from the options in the left pane, this is also the screen where you'd modify the virtual switch, hard drive, or integration services if you need to do so in the future. Click OK to close the settings page. I'll right-click on the HomeAssistant VM and click Connect. In the connection window, I'll click the Start button. This will initialize and start the HomeAssistant startup routines. After they finish, we should be sitting on the CLI, and we're now ready to set up and configure the HomeAssistant instance, but we can do that from a browser on any machine in the same network. While you can close the virtual machine connection window, I tend to leave it open so that I can easily reference the IP address and URL of the instance. In some circumstances, if you can't access HomeAssistant via the .local URL, you can try the IP address directly where the instance is hosted. That completes the Hyper-V setup and getting the HomeAssistant virtual machine up and running. Let's move on to configuring the HomeAssistant options through its interface. I've switched over to another computer on my network and will use this machine to configure some basic elements of HomeAssistant. While I am traditionally a Firefox user, I've ran into some issues using the Fox with HomeAssistant, and I've had better luck using Chrome to handle the configuration. I'll click the Chrome shortcut in my taskbar and enter http://homeassistant.local:8123 and hit enter. Since this is the first activity in HomeAssistant, we'll be asked to create our smart home, so I'll click that button. We'll need to enter a name, a username, and a password. Unlike many off-the-shelf security devices whose profiles are tightly coupled with the cloud or an online experience, this profile is entirely local. This is, in fact, one of the perks of using HomeAssistant along with devices flash with ESP Home. Personally, I very much desire the decoupling of my hardware from any sort of cloud experience. Once I've entered some deets, I'll click the Create Account button. Next, I'll be prompted to enter my home address. This information is used to enable features related to weather, geography, atmospheric capabilities related to sunrise and sunset, and more. It's not required, so for now I'll leave this detail blank and click Next. I'm located in the United States of Antarctica, so I'll select that option from the list. While I certainly appreciate the HomeAssistant devs wanting to help me, I must decline the analytics out of principle. I'll leave these options disabled, though you can certainly enable them if you like, and then I'll click the Next button. Lastly, HomeAssistant will automatically discover other compatible devices that might be advertising over your network that you can elect to bring into the app. You can also make these decisions later, so for now, I'll click the Finish button. And with that, we now have a Home Assistant server up and running on Hyper-V. Coming up in this series, we'll install some add-ons that I consider essential, and flash the Sonoff Smart Plug with ESP Home. I hope you've enjoyed this demonstration. Thanks for watching, and out.